the indirect, correct? Now, some of the liver cells can actually conjugate, so they should be excreting it out. But what happens to a cell when it gets injured?
Cell function goes down.
Yeah, it stops functioning, but it
So
swells. And what about that space of DC? The same. When the cells swell, what happens to it? You block it, okay? So as a result of that, the bilirubin that is conjugated actually can't get out. So you get an elevation in the direct and an elevation in the indirect. Some cells can't make it, so the indirect goes up. Some cells can make it, but then they can't excrete it because they're swelling and blocking the bile liquid out. So as a result of that, you get an elevation in both. Now suppose the block is all the way down here, actually in the bile duct, in the major bile ducts. What's going to happen then? That's going to be mainly direct because it's going to make it, the liver's going to make the normal amount that's coming to it, and it conjugated it, but it's trying to excrete it and can't get it out. So that's going to be a direct acting. This is going to be mainly indirect from either that or occurring within macrophages. Indirect within the liver itself, both direct and indirect, and after the liver, mostly direct. Clear as mud, right? What you're going to have to do is sit down and go through it by yourself. Okay? Think about it. And if you still have questions, yeah.
So the patients that get like a cholecystectomy, would you expect changes in the feces then? If you took the gallbladder out, would you expect a change in the feces because they don't have a reservoir anymore?
No. Actually, that doesn't really have much of an effect. It does initially. And what people that have gallbladders out are told, or if you take gallbladder out of an adult too, the same thing. You tell them, watch out for the amount of fat that you have in the diet, because that's a stimulus for bile secretion. So as a result of that, you don't have that problem. And actually, the liver and the major bile ducts can pretty much still control the flow. What happens in an animal that does not have a gallbladder? That kind of effect happens. Actually, the major bile ducts really do control the flow. So if you take the gallbladder out of an animal that has a gallbladder and don't feed it a lot of fat, they probably will do all right. Okay. So that was a oh, that's the one I wanted to show you. That's the bladder down there, which is full of free hemoglobin. By the way, is free hemoglobin toxic to the kidney, the kidney tubules? Yep, it is. And there's the hemolysis. There's some too. Now, what do you think the difference between this and this is? Where's my simple answer?
doing blood draw.
What happened with this one?
They might have used a small needle lumen and like.
He's there. You lyse the cells yourself. Something you did. It may be the bore of the needle, or it may be that you put it on an ice cold tube. A number of things can happen like that. They cause lysis of the red cells, and that happens. But when you get one that's like this, that's not likely to be the case. What that is actually that was intravascular hemolysis. Now, extravascular could do this one, but not that. Extravascular means you're bringing out more red cells than you normally should in the spleen, and you're getting out more of the indirect actin bilirubin as a result of that, and that can stain your plasma a little red. But that could also be due to mechanical things that you cause. But that is intravascular. Okay. Now intrahepatic, and that's when the liver cells actually can't efficiently conjugate what's coming to them, and what they do conjugate, they can't get rid of. So liver's damaged here, and it's yellow, which probably means fat, and it could mean some bowel accumulation too. And here, liver cells. All through here. And you see these little lines. This is bowel building up in the cannuliculi, all around the hepatocytes, and then some hepatocytes have to have stuff in the cytoplasm. But most of that is the bowel cannuliculi. Now, tell you one other thing about this. If you get a pathology report back of a liver biopsy, and the pathologist tells you you have cholestasis, which means he can see this sort of stuff. You're building up in the bowel cannuliculi and some in the hepatocytes. That's not a good prognosis. Usually the animals don't do well when that's the case. And here you see some that's actually in the hepatocytes there. And sometimes you can get what they call bowel lakes. And this is a large area of accumulation like that. Okay, that's intrahepatic. And then the posthepatic. Well, I did have a picture, but I don't know what I did with it. Anyway, what's the most common cause of a posthepatic? What's wrong with this guy? And that's, yeah, obstruction from what? Well, gallstones. Okay, that's what this is pointing out. This is gallbladder. Now, what are these stones probably made of? Mostly. You remember back when I talked to you about stuff that accumulates in bile, cholesterol, and I showed you the bowel, gallbladder epithelium, which is really pale, you know, from the accumulation of the lipid in there. So yeah, you know, cholesterol stones occur in the gallbladder, and people that have hypercholesterolemia are much more likely to get this than people that don't have it. So these are probably actually cholesterol stones. And what about this? This is a pig. What are these things? Worms. What do they look like? Is it round? Is it flat? They're round. So, probably what's in there? And where they come from? Ascarids. What's the name of the ascarid in the pig?
Something. Macrocantharynchus ruminatus?
No, that's the stomach worm.
Jesus.
I used to like to say that too because it was a big word that made people think I was smart. But
I don't remember. You didn't ask us about this one.
Does it start with an H?
okay.
Oh, Ascaris.
What?
Ascaris.
No?
What does it start with?
What does it start with?
NS. Well, ascaris. Ascaris. And the second word starts with an S. But it ain't suis.
Sweet? Sweet. So which one is correct?
Where's my Google? What'd you find?
Oh, I didn't look it up yet.
You didn't look at it.
Ascaris suum?
Tell them, name. Say it again.
Ascaris suum.
Suum. Okay. So it's an S, but it's not suis. Okay. I know that's a good guess. And most of the time, if you got something in a pig and you don't know what the species name is, hang your hand on suis, but that's not it.
S-U-U-M. I googled it. S-U-U-M.
S-U-U-M.
Yeah, S-U-U-M. So, what would happen to this guy? Would you block the bile ducts? Yeah, so this is the post-hepatic. The most common cause of post-hepatic is really not stones, not in animals. It is in people. But parasites or maybe a neoplasm. So what kind of neoplasm would affect that? Neoplasm of the gallbladder or bile ducts. So what would you call it? While she's looking that up, we can keep going. And in this one, you can also get bile leaks, and that's what that is in the post-hepatic. And this is just a chart that shows you different pigments and what they stain with and what they don't. Okay. You got this, the start of this yesterday. And which one did she talk about?
Type 1.
Type what? Type 1. Okay. That's when preformed photosensitizing pigments are ingested and absorbed. Type 2, that's the porphyria where you have congenital problems with metabolism of heme, and some of the intermediates that build up as a result of that are fluorescent, and they will cause the same kinds of problems. And then the third one usually occurs in herbivores, and that's due to the liver's inability to metabolize phytoerythrin, which is one of the breakdown products of chlorophyll, and that fluorescence causes the problem.
Metabolite what?
Can you repeat the third one?
The third one.
And the third one is due to liver damage, and that's the inability to metabolize phytoerythrin, which is a byproduct of chlorophyll. Okay? So why did I say it was more common in herbivores? What are they eating? Plants, most of which have a large amount of chlorophyll. Okay. So let's go through these things quickly. Preformed pigments, porphyrin, and phytoerythrin. Those are the things we just talked about. Okay. Type 1. Yeah, those are the three causes. Preformed pigments, and now we're going to go through and show what some of the preformed pigments are. We're going to show you about the congenital one or the inherited one, and we'll show you some liver disease and the other. Okay. So here's type 1, ingestion of preformed pigments, photosynthesizing pigments, and this is usually in herbivores again, but not always. And I'll give you an example of when it's not always. Here are some of the plants that can do that. Hypericum, that's this plant. Phagopyricum, that's this one. And that one is the one she showed you. What's that? St. John's wort. And that's the one that you don't have to be a herbivore to ingest this. Some preparations, holistic medicines and things like that contain St. John's wort because it's supposed to stimulate the immune system, and it's also supposed to stimulate memory and that sort of thing. And I don't guess Dr. White will mind me telling this story about her. We had a dermatologist here, many years back, and Dr. White gave her daughter some of these holistic products that had St. John's wort. And her daughter came home one day itching, skin's bothering her. And that night, things kind of cooled off, not much of a problem. She went to school the next day, and said, bothering me again. What was she doing? What's it doing outside now? sunshine. She was going out in the sunlight. She gave a product that had St. John's wort in it. And she didn't think of it, dermatologist, but she didn't think about that. And after about 3 days, she said, ah! Yeah. So that's what happened. Now, the child, of course, is not herbivore. So she got it as a result of ingesting the medication that had it in it. So non-herbivores can get this if they ingest the product. But, you know, most dogs and cats don't go around eating St. John's wort. Okay. So here's the dermatitis you see. And it's on the nose and on the head here. And that's as a result of eating those things. Type 2, this is the congenital one, where there's a problem with metabolism of porphyrin. And this is one of the things that shows the metabolic pathway for metabolizing it. And the answer is no. Right away, you say, no, you don't have to memorize this. So, now I'm not telling you she won't get to do that. Well, not me. So, when you get a block in one of the enzymes that's supposed to carry this stuff to another thing, these things build up. And a lot of these things are fluorescent, so they can cause a problem. And here's a calf. And the severe dermatitis is due to photosensitization, and it was genetic in him. It had porphyria. It had some other things. This is the bone from an animal that has the porphyrin built up like that. And here's the bone from a normal animal. So you can see this discoloration that occurs. And if you put it under UV light, it will fluoresce, like over here. And if you look at the teeth, they will also have the discoloration, and that's why it's called pink tooth, because his teeth look pink. The normal animal over here. And it occurs in cats. And she was right, it's more common in cats than it is probably any other domestic animal you know about. But it does occur in pigs as well. And here's a cat. So which one is that on? The one over here. That's the discoloration, that's normal teeth. And actually, you can get the skeleton to fluoresce. Yeah. And this is in people. And we got time for a story. He was normal until he got out in the sun. He was normal until he tried to drink some water. Why did I say until he tried to drink some water? Or when he looked in the mirror, he didn't see his reflection.
No.
And he's from Transylvania. So, actually, he might have been from Transylvania. But people with porphyria were thought to be vampires. Why? Is because they would be anemic. And they would seek to get blood proteins and stuff, so they drink blood. Mostly cow's blood, that kind of stuff. But anyway, they would be very sensitive to sunlight. Okay? Because of the damage in their mouth, they'd have trouble drinking. So, and guess what? This gene for causing this disease is much more prevalent in Transylvania than it is in other parts of the world. So that's where this legend of, quote, Dracula came from as a result of that. Now, there was really a guy named, well, if you don't pronounce it Dracula, Dracula is actually how you would say it. But he had this propensity for fighting his enemies by driving a stake through them. Yep. But anyway, this legend came about from that. That's the story. That people used to think people with porphyria actually were vampires. That's not true. And you can see the teeth fluorescent here. And we got a kitty cat. Okay.
There we go.
So what do we say this stuff is more common in? Cats. So here's this cat, and if we look at him closely, what do we see as far as his teeth are concerned?
There.
They're kind of brownish, which gives you a clue what might be going on here. And what else is wrong with him?
His gums? I can't tell.
What's up with this guy?
What else is wrong with him?
This guy.
Does it sound like he's got a congenital thing? He's 10 years old.
No.
Yeah, but he does. Because actually in cats, it takes a while for this stuff to build up. So, what's the complete blood count show you?